Hi everyone, welcome to another Choreo Community Call session. In today's session, we'll be looking at how to monitor and troubleshoot applications that you have deployed in Choreo. My name is Nilushan Costa and I'm working within the Choreo observability team. In today's session, we'll be going through the importance of observability and how to use these observability features to look at the applications that you have deployed on Choreo. I'll first present to you some slides where I'll explain the importance of it, and after that, we will go through a small exercise to see how we could use all these features. If you have any questions, you can post them in the YouTube chat, and we'll get to these questions at the end of the session. So far, in our community call series, we introduced different features of Choreo. We explained to you how you could get started with Choreo, how you could deploy your applications in Choreo, and how you could use them to serve traffic. When it comes to deploying something in production, an enterprise-grade application, the journey does not stop once you deploy it. Sure, it would take some time to build the application and deploy it, but afterwards you cannot stop. To ensure that your application is working properly, you need to monitor it, and if there are any issues over there, you need to know how to troubleshoot and fix them. So in this session, we are going to concentrate on those things. But why do you need to monitor an application once you deploy it? Well, there are several reasons. Applications that we deploy nowadays don't run in isolation. These programs, these applications, they interact with other systems. Let's say you deploy an API in Choreo. This API would be talking to other systems in the backend. It may be consuming APIs from other external parties or from your organization itself. So when these different systems interact, there could be issues that could come up. So you need to monitor them to ensure that everything is working smoothly. And then code changes can introduce bugs. So when you do a code change, you don't want to deploy it directly to production. You want to deploy it to a lower environment, test it over there, and once everything is working properly, you can roll out the changes into production. And to do that, you need to test your application and monitor it while it's in a lower environment. And then when you write an application and deploy it, you expect it to perform in some given way. So once you deploy it, you need to make sure that it is performing at that expected level. Because at the end of the day, these applications are using resources. You could be deploying it in some cloud provider, you could be deploying it on Choreo, or you could be deploying it in some bare metal server. No matter where you deploy it, it is using some resources. So you need to ensure that the resource usage, the performance that you get through that is at the expected level. Now, when you monitor applications like that, it leads to an observable system. When it comes to monitoring, it talks about gathering different metrics and analyzing those. So if you use monitoring, you can look at metrics individually. But to get a good idea about a system, you need to look at all these metrics and the logs as a whole and observe the entire system. So once you have proper monitoring in place, it leads to observable systems. So that's why monitoring is important. So how do you monitor and observe applications? Let's say you develop your own platform to deploy your business applications. If you do that, you will need to spend some time to set up observability tools. It is certainly possible because there are so many free and open source tools that are available at the moment. Or you could go for a paid platform and integrate observability into your own platform. All this is possible. Let's say you choose some free and open source tool to look at logs in your platform. To deploy that, you need to do some things, some extra work into your application. First of all, you need to set up some CI/CD pipelines in order to get these observability tools into your platform. The main reason is when you deploy an infrastructure tool like this, you don't just deploy it once and forget about it. No, you can't do that because from time to time you may need to do changes to it. You may need to do updates to it, and so on. So if you want to do them smoothly, you need to have some CI/CD pipelines built in. So setting up that takes time. And then most observability systems deal with data. These could be metrics or logs. And since this data is what helps you to debug your applications or to understand what went wrong, if something goes wrong, you don't want to lose that data. Therefore, you need to ensure that you have proper backups. So you need to either automate them or make sure that you take these backups on a constant basis. Next, the version updates. The tools that you install, the infrastructure tools that you install to get observability working would have updates from time to time. So you want to have these newer versions because they may include bug fixes or some new features. So you need to look at these updates and then deploy them into your platform. And if it's a live platform, you can't just deploy a new version. You'll have to deploy it in a lower environment, test it, make sure it works with your platform, and finally deploy it into your live platform. And then there are security fixes as well. So from time to time, various vulnerabilities are discovered. And to ensure the security of the platform, you need to deploy these security fixes as well. So you'll have to use the CI/CD pipelines that you built to deploy the patched versions. And finally, you need to integrate this tool with your own platform. So there could be some issues that may come up during integration, but if you're running your own platform, you need to solve them so that everything works smoothly. Now, when you build a platform and build observability into it, it takes time. It's certainly possible, but it's a bit difficult. Is there another option or another path that we can take? Yes, there is. The other option would be to go platformless and use the observability features that comes with it. Now, when we try to build our own platform, we have to spend some time to plan it and to maintain it. And the time that you spend on that platform includes the time that you spend for these observability features as well. But most of the time, the purpose of having a platform would be to serve your business applications to your customers. So if you could focus on your own applications and use a platform that is already available, you don't have to spend all that time or all that effort to get observability working. And that's the advantage of going platformless. The platform that you start using would already have observability built in. So you just start concentrating on your own application. This is somewhat similar to buying a car. See, most of us, if we are not car enthusiasts, we buy a car to get us from point A to point B. So when you get into the car and start it and start driving, you expect to see all the information that you need. You don't buy a car and start installing fuel sensors, tachometers, and everything. You just drive the car and expect to see that information on the dashboard. Likewise, when you go for a platformless experience with something like Choreo, you deploy your application and observability would already be there. You don't have to do anything else. You can just start using it. And all that overhead about maintaining it is gone because everything is already there. Now, Choreo being a platformless product already has some observability features built in. Let me go through some of these features. So first of all, we have this usage insight feature where you can look at your application from an API level. See, when you deploy a service on Choreo, you may expose it as an API. And when requests come to this component, they go through an API gateway. If you go into the usage insights section, you can see how well your application is performing at the API level. Next, you can go into the component, into the application itself, and see how it will perform after it passes this API gateway. We have different menus or different views for you to do that. For example, what you see on the left side of the screen right now is a service diagram, which shows you how the components in an app, how the components in a project are working with each other. Or if you want, you can drill down into a particular component and see how well it's performing. And that's metrics. Next, we have another important pillar of observability, which is logs. Logs help you understand what's going on within your application. Because when developers write these programs, they know the architecture of it. They know what is happening. So they can add some logs into it so you can understand from the outside whether it's performing as expected or not. And within Choreo, you have different types of logs. You have runtime logs to understand how well the program is running. And then you have audit logs to understand what is going on within your organization. And when it comes to observability within Choreo, we provide observability at different levels. The diagram you see on screen right now is like a logical organization of projects, components, and organizations in Choreo. Now, we provide observability at various levels. If you want to drill down into details about a particular component, you can look at observability at the component level. But if you want to see how multiple components are interacting within a project, you can go into the project level observability and look at service diagrams and logs. Or you can look at audit logs at the organization level and see what has been going on within your organization. Next, during the next part of this session, I will show you a demonstration how we could use all these observability features. Now, before that, let me just go through what we could do with Choreo observability. We could start with the smallest, that is looking at metrics like CPU usage, the memory usage, throughput, latency, in order to understand how well your application is performing. That would be like the basics. Next, we could see how various components are communicating. In Choreo, you deploy components, and all these components reside within a project. So a project contains related components. And if we want to see what's going on within this project, you want to see how these components are communicating with each other. Because when these network calls happen, there could be issues that pop up. So with correct observability tools, you can see whether the communication is happening properly, whether the communication is happening in the expected path or not. And then logs, as I mentioned earlier, they give a lot of important information about your application. Within Choreo, you can look at logs at a component level, or you could zoom out a little bit and look at logs from a project level. And if we want to correlate logs, you could also do that with Choreo. See, the thing is, when you deploy an API in Choreo, the requests come through the API gateway. So the API gateway would be emitting some log. And then your actual component, your API, would be writing some other log. You don't want to switch through different screens, so you could see what's going on in the API gateway and then what's going on in the component. With Choreo, you can see all this in a single view, in a single runtime logs view. So all these observability features that we have built into the platform would definitely help you to debug problems. So during this part of the community call, I will show you how to do that. Let's do a small exercise. I have already deployed a project in Choreo, a microservice project, and it has some components. At the beginning of this demo, I won't reveal how they are communicating with each other or the architecture. I won't show any code at the beginning as well. Let's try to use these observability features to see if we can get an understanding about this application. I already created this application in a project called the observability sample. Now, as you can see, this project has three components: a department service, an employee service, and an HR service. All these are service type components in Choreo. Now, this is not serving any live traffic, so we can play around with it. And that's what we'll do right now. So let's just go into these components to figure out what they are. So the department service has been deployed into production. Uh, let's try to send some requests and see what will happen. Okay, so it's not deployed into the development environment, but it seems to be running in production. Okay, but unfortunately, we can't send request to it because the visibility of that component is set to project level. Now, what does project level visibility mean? When you deploy a component in Choreo, you can set different network visibility levels. These are project, public, or organization. If you have a component that has project level visibility, only components within the same project can send requests. Now, when we use this test console in Choreo, the request starts from my browser and it goes into the component. But since it's having this project level visibility, I'm unable to send requests through that. So looks like department service cannot be invoked. Let's try something else. Employee service. Okay, employee service is deployed in production and yeah, looks like we can send requests from the test console. Now, from this, I could see that it's expecting an employee ID. So let's just start with ID 1. Okay, the request went through, but I'm getting an HTTP 502 error. Looks like there's an issue with the HR service. Uh, let's see what's going on over here. Hmm. Okay, so for some reason, it has been undeployed from both environments. Now, I think before the community call, I might have pressed something and undeployed it. So we'll just go ahead and redeploy it over here. Now, suppose something like this happened in an actual production component. You don't want to just go and redeploy it. You want to find out what happened. In a situation like that, you can use the audit logs feature that's available in Choreo. To access the audit logs, you can go into this organization view, click on DevOps, and go into audit logs. The audit logs view provides an audit trail of what happened within your organization. So if we scroll down, yeah, looks like I have undeployed it by accident. So according to this audit log, it's the HR service in production and it has been undeployed by me. So you could use information like this to figure out if something went wrong within your organization. Maybe someone gained unauthorized access to it, someone with a malicious intent undeployed a live component. So those things could be figured out using these audit logs. Now, since we have deployed the HR service again, let's send it another request and see. So we are back in the employee service. We'll go into the test console, select the production environment, and send a request to it. Okay, I don't seem to be getting the 502 error, but it's taking a bit of time. Okay, I got a response with an HTTP 200 code. That means it was successful. I got some information about some employees within this company. So we have its name, the designation, and the department they are working in. So looks like this system is there to provide the employee ID and get information about the department they are working in, their designation, and the name. Okay, so the high latency wasn't an isolated incident. It seems to be happening all the time. Let's see if we can look at these metrics and figure out what has been going on. First of all, since I have exposed this as an API, I could look at API level metrics. And to do that, we can go into this usage insights section that I mentioned earlier. It works at the project level. So you can select this observability sample project. select the time range that you want, and I'll select the production environment. So according to this overview, it has been getting requests. Some of them have been successful, but uh, it's a bit concerning to see some errors over here. And the latency that we experienced earlier has been recorded here as well. So there seems to be some sort of a bottleneck in this microservice application. If we dig a bit into this latency, we can see that it's always having something like a 10-second latency. And it's not happening only now. If we go, it has been happening in the past as well. If we check the data from last 7 days, we can see it always having this 10-second latency. So that's an issue. Let's see if we can figure out if it's an issue with the component itself. Now to do that, we can go into this components observability view. To do that, I can select this employee service and then select observability metrics. I'll select the production environment and let's look at the data for the last 24 hours. This view over here shows us the throughput that our component experience. It shows a successful request as well as a failed request. So according to this, there were successful requests to my application, but there were failed requests as well. And if we look at the latency graph over here, we can see that it always takes more than 10 seconds to get a response. So that's a bit of an issue. The API metric that we saw earlier is correct when it comes to this component level metric as well. Let's try to go through all these components to see if the latency is recorded everywhere. So this is the employee service that I sent request from outside. Let's go into something like the department service. So again, I'm at the department services observability view, and this is component level observability for this particular component. And that too is experiencing high latency. I could still see about a 10-second delay over here, but fortunately we don't have any errors over here. We have successful requests, but it's taking a bit of time to get a response. Let's check the HR service as well. Okay, so the HR service is getting a successful request, but there are errors as well. However, the latency over here is not that high. It's like 3 seconds. So let's pause for a moment and see what we have gathered so far. We have a microservice application consisting of 3 components: the HR service, the department service, and the employee service. HR service and department service are not directly invoked. We invoke only the employee service. And looks like some communication is happening between these components and the request flows through all these components. 2 components are showing errors, that is the employee service and the HR service, but the HR service does not have a very high latency. If we think about the architecture of this microservice application, there are 2 possibilities for this. One is that the employee service sits at the front, it receives the request, it sends it to the department service, and the department service invokes the HR service. The HR service has low latency. That's what we saw in the component level metrics view. But for some reason, the department service might not be performing properly, and it's adding some latency. So it's possible that we have the architecture shown in number 1 in our application. It is equally possible for it to have the architecture shown in number 2 as well. The employee service receives the initial request, but it's the one who's calling both the department service and the HR service. And there is no communication happening between department and HR service. Both these architectures are possible. If we are looking at component level metrics, although we can see a lot of detailed information about what's happening within the component, we can't get an overall picture about the entire application. If we want to get an understanding about an application that way, to understand how they are communicating with each other, we can look at project level observability. Project level observability helps us to observe our components at the project level. To do that, we can go into the project level, go into observability, and click the metrics menu. We'll look at only the diagram for now. And I'll just change some of these filters. So the view that you see right now is a service diagram, and it's represented using cell-based architecture. And from what we can see over here, the architecture that we have is the one shown by number 2. We make a request to the employee service, and employee service invokes department service and HR service. There is no communication happening in between. Now, this diagram, which is based on cell architecture, tells us that there is an external request coming through an API gateway, and the employee service receives that request. The employee service, department service, HR service are all components within this project, which is represented by this octagon. And employee service sends requests to both of these components. And since there is no path shown between department service and HR service, we know that there is no communication happening between those two components. And there are no lines originating from within the octagon to the outside. That means there is no communication originating from any of these components. If we look at the metrics that are shown in these paths, we could see the request count, we could see the error percentages, and we could see the latency values. So according to these metrics, we have the high latency recorded over here, and we have an error percentage of around 22%. And we could agree that these values are correct with respect to component level observability as well. Let's see about the communication between these other components. So from employee service to HR service, there are some errors, but the latency is low. And for the communication between employee service to department service, there are no errors, but the latency is high. So the bottleneck in our application seems to be centered over here. If the department service was sending requests to outside parties, we could have assumed that the delay would be caused by some external system. But according to this diagram, we don't see any requests originating from department service. So that can't be it. There are two other possibilities. One would be that the department service is doing some computationally intensive calculation, and it doesn't have enough resources to do that. So it's being slowed down over there. Or else, when it sends the request from employee service, it goes into a particular request path in the program, and that is causing this high latency. And both these are equally possible. Now let's see how we could figure out which of these is the actual issue. Now, if you want to learn more about the cell-based architecture, about what these different symbols over here mean, you can look at the cell architecture, the reference architecture. We will provide a link in our YouTube video's description. But for now, let's try to figure out where the issue is. So we can go into this department service and look at some other metrics. And to do that, we can click over here and go into the observability view of the department service. Since we already looked at throughput and latency, let's look at some other metrics. To do that, we'll go into the diagnostics view. Now, the diagnostics wave provides metrics from multiple sources and it helps you to correlate them. So, the metrics that you see over here are the error rate, the throughput, the latency, the CPU usage, and the memory usage. Now, having all these metrics together helps us to understand whether one metric is causing a problem with another. For example, whether the high latency is caused by high CPU usage. Let's see if we could get some information about that. So I can see some latency spikes over here, and then there are some CPU spikes as well. But the latency spikes and the CPU spikes don't always happen together. There is some correlation at times, but by looking at this diagram, it appears to be some spurious correlation at some points in time. Because if the program was slowed because it didn't have enough CPU resources to do the calculations, we should have seen high CPU at every point where we see high latency. But that's not the case. So these are spurious correlations over here. Uh, the errors and the throughput values are also shown, but it doesn't really give us an understanding about why we are seeing this high latency. If you look at the CPU usage, it seems to be not that high. It's just 2 millicores, 5, 10 millicores, and it seems to be a very small amount. And I think the component is having much more CPU available to it than that. Let's verify it in a bit. But we don't see any correlation between high CPU usage and the latency. So it's not the CPU being a bottleneck that is causing this problem. Let's verify how much CPU our component is getting. To do that, we can go into the runtime wave in the DevOps section, select the production environment, and we can see that it's getting 500 millicores of CPU. So as per the metrics that we just saw, it wasn't using all the available resources. So it's not a bottleneck with CPU as well. Now, the other possibility is that when the employee service invokes our department service, it goes into a particular request path, and that is causing this high latency. We could verify that if we were able to send requests to this department service directly. But unfortunately, in the production environment, we can't do that because department service is exposed as a project level component. But we do have the dev environment available. So let's try to do some debugging over there. When you go into the deploy wave in Choreo, you can see multiple environments. For this particular organization, there are two environments. One is the production environment and the other one is the development environment. The application is running in the production environment. I don't want to do any changes to it because if it's like a real scenario, you don't want to disturb live traffic when you're doing a debugging. So let's try to use the development environment to invoke the department service directly. To do that, we can change the network visibility only for the development environment, and we'll invoke it and see if we are still seeing a high latency. Okay, it's the network visibility is now set to public. Let's go ahead and deploy it. And the application is having the same commit hash in both production and development, so it's the same code that is running. Let's go ahead and send some requests directly to the department service. Now, once we send these requests, if we get a response much faster than before, that means the issue is not isolated only to the department service. The problem is happening when the employee service invokes the department service. But if we see the high latency when we send requests now as well, that means the issue is isolated to this department service. So that also seems to be accepting a path parameter department ID. let's just try with ID1. Okay, so looks like it's a bit slow to respond. So I think we are going to see that high latency issue again. Let's just give it some time. Yeah, so I got a response with an HTTP 200 status code. I got the information that I wanted, but it's performing a bit slow. So looks like the bottleneck in our application is isolated to this department service. Let's send it one or two requests more. And after that, we'll use the metrics view again to verify if that is the case. So all these requests took a lot of time. And if we go into the project level metrics observability view, we'll be able to see the service diagram again. And this time we'll switch to the development environment. And as you can see, my request originated from outside and we invoke the department service directly. And that is having high latency. So at this time, we are sure that the issue with our application, the bottleneck in our application is caused by this department service. Now, it is probably some issue with the code. It's not some problem which is using a lot of CPU, but it's possible that there is some mistake in the code. We could just look at the code and see. We'll go back to the department service. I deployed this through GitHub. Mm, Let's open the source code and we can go into the department service. This is a Ballerina application, Ballerina service. So when it receives a request on this port, it will check the departments that are defined in this map and it seems to be responding with that. So we have the departments map consisting of 4 departments, and when we send a request to it, it's checking if that particular department ID, a department with that ID exists in this map. And if we don't have anything, it's responding with a 404 status code. And if we have it, it's responding with the correct department. Okay, so looks like we found the issue. For some reason, we wanted to add a sleep for 1 second, but by mistake, looks like we have added an extra zero as well. So this seems to be the root cause of the problem that we saw during this exercise. By this now at this time we know what the issue is. So to fix it, we could update the code, we could deploy it to development environment, do some testing, and then promote it to production. But that part is out of scope of today's community call. But you could certainly do that when you have your own applications. Now, what did we learn through this exercise? When we started this exercise, we did not have an idea what our microservice application was. We just knew that we had an application and that it had several components, but we didn't know how it was communicating with each other. We did not look at the program code when we started this exercise, but by using all these observability tools, we were able to understand what was happening within the program. And then we were able to look at the performance of the application at different levels using various observability features. We saw how each component was performing, and we saw how everything was performing together. And finally, we were able to identify that the bottleneck existed at the department service. Now, for this particular exercise, we were able to use only the metrics and figure out the problem. But there could be cases where you could look at the logs as well. So I will show you some logging capabilities within Choreo. If we again select a component and go into observability runtime logs view, we are able to look at logs at the component level. Now, according to these logs, I could see some gateway logs, and I could see some application logs. Now, this is the correlation feature that I mentioned earlier. So if we look at this single runtime logs view, we can see logs from both these components. That is the component that I wrote, which is this department service, and the Choreo's gateway. By correlating these logs, we can identify if there are issues. Let's go to a different app component and see whether we can see some other gateway logs. Okay, so we have this 502 errors that we saw earlier, and that is from the production environment. And then thereafter, we could see the application logs from the employee service. And all these could be filtered based on the type of log, whether you want to see only error logs, whether you want to see only gateway logs, or everything together. You can even filter by environment. You can filter by time range or the deployment track. Now, this is runtime logs at the component level. There may be situations where you want to look at logs from all the components. If you deploy this on your local environment or your local computer, say, you might have to go into different terminals and look at logs from each component. But with Choreo, we have this project level runtime logs where you can see logs of multiple components in a single view. Here we are looking at the observability sample again. And as you can see, there are logs, these application logs from the employee service, from the HR service, and the department service. Now, the advantage of something like this is you can see what happened with the request. You can see that the employee service received the request. You can see that it went back to the HR service as well. Likewise. And if some errors occurred while this was happening, through this project level runtime logs view, you can understand where that error occurred. So with that, we come to the end of the exercise as well. And that brings us to the end of today's community call. If you have any questions, you can send them to us through the YouTube chat, and we'll be happy to answer all those questions right now. Okay, so looks like we don't have any questions at the moment, but if you watch this recording at a later date and if you want to clarify something, you could certainly add a comment over there and we'll check and get back to them later. But for now, I hope that you were able to understand something about monitoring and debugging using today's community call. Today we went through the observability features that are available in Choreo, and we looked at why it's important to use observability with a platform-less product, because you don't have to worry about what's happening underneath. You can just deploy your application and start using all the observability features. And then we looked at the observability features that we had. We looked how we could debug applications at different levels, at component level, at project level, and finally to figure out where an issue in a project is. So thank you all for joining. Hope you have a great day.